So the base of a cone is a circle, and the point at the top is called the vertex. Now let's first talk about cross sections of a cone. If you slice the cone parallel to the base, like how it is right now, you see that you're going to get a circle. If you slice the cone through the vertex at the right at the top, perpendicular to the base, you will get a triangle. And another cross section is, what if I slice it diagonal? Well, in that case, you'll get an oval, but in math, we don't call it an oval, we call it an ellipse. So as we said, parallel to the base, you get a circle. Perpendicular to the base through the vertex, you get a triangle. And then diagonal, we get an ellipse. And maybe in parentheses, you might want to write oval next to it, just so you remember what an ellipse is. Now we're going to actually find the volume of a cone. Now the volume of a cone, it's right on your reference sheet. It's 1/3 of a cylinder. So the formula is 1/3 pi r squared h. Okay, so in number 1 here, let's calculate it in terms of pi. The radius is 5. We already have it right here. And the height is not 13, actually. The height is from the center point of the circle straight up through the vertex. So we actually don't have the height right now. Well, using what I've traced and kind of connecting these, we form a right triangle because the height is always perpendicular to the base. So here's a right angle. I don't know the height. I'll call it h. Well, we have two sides of the triangle. We don't know the third. We're going to use Pythagorean Theorem. A squared plus b squared equals c squared. So as I plug those into the Pythagorean Theorem, remember that the c has to be the hypotenuse. The c is going to be 13. Okay, so square the 5, we get 25. Square the 13, we get 169. You subtract from both sides, you're going to get h squared equals 144. And at this point, you're going to take the square root. Now, if you get a long decimal, well, you're going to have to write down that whole decimal because we're not done with this problem. But we're lucky because this one comes out to be just 12. So I go back and I'm going to plug in 12 for the h. Now, when you're writing your answer in terms of pi, remember, when you put this in the calculator, you're going to type it in. Just don't type pi. So I'm typing in 1 divided by 3 times 5 squared times 12, and I get 100. So it's 100 pi. Sometimes what happens is you have a problem where you have to work backwards, and that's like number 3. The volume of a cone is 600 pi cubic inches. So I'm first going to write the formula for the volume of a cone, again, right from your reference sheet. I'm going to put 600 pi underneath the v. Okay. Now, we know the radius is 1.25 feet. Well, we have a problem right now because then it says find the height in inches. I can't solve this in inches and in feet, so we need to convert to inches. Now, the volume was already fine, okay? We just have to convert the radius here. So 1.25 feet, how many inches is that? Well, in the calculator, you can just do 1.25 times 12, and you get 15. Think about it. 1 foot's 12 inches, and then 1/4 of a foot, you're going to add another 3 inches. So you get 15 inches for the radius. Find the height. Well, I don't know what it is. I'll leave it as h. At this point, you want to solve for h. Well, if you divide both sides by pi, the pi's will just cancel out, and you're going to be left with 600 equals 1/3 times 15 squared times h. In the calculator, I'm just going to type 1 divided by 3 times 15 squared, and I get 75. So 600 equals 75h. Divide both sides by 75. Okay, now let me type this in here. 600 divided by 75 is 8. So our answer is 8 inches for the height. Okay. We're going to skip number 4 and go to number 5. So number 5 says a candle maker uses the mold of a cone to make candles. The height of the candle is 130 millimeters, and the circumference at its widest measure is 31.416 centimeters. Right there, we notice something's going on. We have to make a conversion. Use modeling to approximate how much wax to the nearest cubic centimeter is needed to make the candle. Well, it tells you in the first sentence that you have a cone. And if you think about it, the wax would be going inside of the cone. You'd wait for it to cool down and then take it out, and you would have the candle. All right, well, formula for a cone is 1/3 pi r squared h. Now, I have the height, right, in the second sentence here, but it's in millimeters. So we have to convert it. So King Hot Dog drank cold milk. We're on millimeters, which is the M. We need to convert it to centimeters. I would move the decimal 1 to the left, therefore getting 13 centimeters. So eventually when we plug that in, we're going to plug in 13 for the height. I don't have the radius. I have the circumference at its widest measure. So basically what that means, if I go up to, I'll go up to this number 2 here. The outside of a circle is the circumference. It's basically saying that right there. That's what you have. Well, I don't know. I don't want that. I want the radius. I want to figure out what this is. Well, it gives you the circumference. Use the circumference formula. Go to your reference sheet. It's 2 formulas for circumference. But since we need the radius, might as well use the one that's 2 pi r. Okay, so we have the circumference is 31.416 centimeters, right? Equals 2 pi r. I want to find the radius. So I'm going to divide both sides by 2 pi. And you guys have to remember here, well, that's going to cancel. But over on the left side, type this in. Because when you type it in the calculator, you have to put parentheses into, hold on a minute. Can't talk and type at the same time, apparently. You have to put parentheses around the 2 pi. Otherwise, the calculator is going to give you a different answer. So I'm just going to go like that. That's what you want to do. Okay. We can't round here. We're not done. So we get 5.00000011692. That's the radius. And now we can use that answer and substitute in for r. So now I'm back in the volume formula again, okay? So the radius was that number we just found when we used the circumference formula. Okay, so I'm typing this all in for r. It's r squared. The height, remember, we converted it from millimeters to centimeters, and we got 13 for the height. And the question says to the nearest cubic centimeter. So type everything in, including the pi. And I get, what do I get? I get 340. So the volume is 340, and it says cubic centimeters. So centimeters cubed. Number 6, a company is creating an object from a wooden cube with an edge length of 8.5 centimeters, a right circular cone with a diameter of 8 centimeters, and an altitude's another word for height, of 0.08 meters. Okay, we have centimeters, meters, something left to be converted, will be cut out of the cube. So you have a cube, you're cutting out a cone. Well, what do we do when we cut something out? We subtract it, right? Calculate the volume of the remaining wood to the nearest cubic centimeter. So we're going to find the volume of the cone. We're going to find, first let's do the cube. We're going to then find the volume of the cone. And if we only want the remaining wood, that means we're subtracting out the cone. Now, what has to be converted here? We want cubic centimeters. So the cube will be fine because that's already in centimeters. The volume of a cube is length times width times height. And it says the edge length is 8.5. So remember, it's all the same when you have a cube. So 8.5 times 8.5 times 8.5. Okay, no rounding at all here. Let's see what we get. So you're raising it to the 3rd power if you want to shorten in the calculator. You get 614.125. All right, let's do the cone. So the cone is 1/3 pi r squared h, right? The radius is, well, it says the diameter is 8 right here. Diameter is 8 centimeters. Well, that would make the radius 4. So 1/3 pi, here's the radius squared, times the height, that's the altitude, but we have to use King Hot Dog drank cold milk again because we don't want meters, we want centimeters. Meters is the line in the middle, the unit, okay? We have meters. So we're right here on the line. We want centimeters. We have to move 2 to the right. So 2 to the right would make it 8 meters. So the height is 8. So 1/3 pi. Why am I writing this? Ah, I can't go back. I got it on a different screen. Sorry, at this point you can put it in the calculator. We're going to have to type it all in because it says to the nearest cubic centimeter. But actually, check it in terms of pi because we're not done. So maybe at this point we'll get a nice answer and we don't have to copy, you know, a long decimal over and over again. Well, we get a repeating number in terms of pi. So you know what? I'm putting the pi in. All right, so everybody type that whole thing. Type it all in. Put it all in the calculator. I'm going to write the full number here because we're not done. And again, we're doing the cube minus the cone. The cone's inside of it. We don't want the cone. We're taking out cube minus cone. I don't feel like copying this number with that whole with the whole long cone number. So you know what you can do on your paper? Just write down you're doing cube minus cone. So you're showing some work of what you're subtracting. And when you subtract those two, you get nearest cubic centimeter. You get 480 cubic centimeters.